Hello, everyone. Well, this is Girish Chowdhary saying hello to you from Detroit, Michigan, where I am for the International Robotics Conference, IROS. I'm a professor of robotics at the University of Illinois Urbana-Champaign. I'm also a co-founder of EarthSense. I'm originally from India, and I've been all over the world, but I always love coming back to India and collaborating on agricultural topics in India, primarily because I come from an agricultural family. Nowadays, I'm in Illinois. Since 2016, I've been here, and Illinois is the kingdom of corn. Most of the Midwest is. Of course, corn is also grown quite a bit in India now, and there is a lot of work in increasing corn productivity in India. But corn is a difficult crop to grow. It's the largest crop that's grown, but in terms of sustainability, it's quite difficult. Corn growing is becoming a riskier and riskier business. There's been quite a large jump in bankruptcies in the US. Herbicides that are often necessary to grow large-scale corn monocultures are now failing across the world, including in the United States. Soils are being compacted, they are suffering from erosion, and there is significant nutrient loss due to the large-scale, unsustainable monoculture practices that we're using. And even with all of this, the yields seem to be falling behind demand. To reverse some of these trends, we're at Illinois and at the Center for Digital Agriculture at Illinois are looking at AI and robotics and other technologies to see how we can create more options for farmers. I am personally the director of the Illinois Farming and Regenerative Management Testbed, which is also the Farm of the Future site funded by USDA, the only such site in the nation. The Farm of the Future is an agricultural testbed where commodity crops and livestock are farmed using synergistic and sustainable practices. Involves a lot of the technologies that we have developed at Illinois and in the surrounding ecosystem with an extension component and engages industry quite a bit. There are many thrusts at the Farm of the Future, including remote sensing, robotics, internet connectivity in rural areas, integrating animals into the farms in Illinois and in the Midwest, technology access to smallholder farms, and understanding the socioeconomics of adoption. Today, I'm going to talk a lot more about the under canopy robotics part of this, including the work that is done by EarthSense at the Farm of the Future. Summarizing all of this, we believe that farms of the future will start with better seeds. They will reduce chemical usage. They will integrate different forms of agriculture together, moving away from the large-scale monocultures we have into productive ecosystems. So in a sense, we believe that robotics and AI will make farming sustainable and profitable by alleviating the labor bottleneck. In Illinois and in the Midwest and in many modern agricultural states, large equipment is used to automate a lot of the farming. This is causing a lot of the problems. We talked about nitrogen runoff, and a big problem is, of course, the rise of herbicide-resistant weeds. And overall, it seems like the trajectory of these developments is going to result in significant losses because these farming techniques are not sustainable. Now, in India, we see labor crisis in a different form. In India, farmers cannot really afford large equipment. So farmers rely on manual labor to perform tasks such as weeding, but manual labor often prefers higher paying jobs in the city. So there is a large labor crisis in rural areas in India. How can robots help here? This is the question that we asked in 2016 when we founded EarthSense. Since 2016, EarthSense has deployed more than 160 robots, has done a lot of interesting and exciting work in agriculture. And today I'm going to talk about some of that work and also about some of the products that EarthSense is launching in India. EarthSense has 4 primary products: the phenotyping product TerraSensia robot, the TerraSensia Plus, which is a modular phenotyping platform, the Terrapreta, which is a cover cropping robot, and the TerraMax, which is a robot that's meant for orchards and in particular for oil palm. So let me start talking about TerraSensia first, then I'll stop a little bit on Terrapreta, and then we'll finish talking about TerraMax. TerraSensia is designed to help in high throughput phenotyping for crops such as corn. Corn, as you may know, is actually not a natural crop in the sense that it was selectively bred from teosinte from Native Americans over 10,000 years ago. Only 3,000 years or so ago, we start seeing the modern varieties of corn. Of course, we need to accelerate the pace of breeding if we are going to feed the 10 billion people we're about to become. In order to do this, researchers all around the world, including in India, are trying to understand the relationships between genomes or genotypes, environment, which includes fertilizers, weather, and herbicide treatments, to the phenotypes or the expression of nature and nurture on what actually happens in the field. In order to do this, they have to run massive scale trials. So this is an example of a sorghum trial in which, if you see these grids, are different varieties of sorghum that are grown in a similar environment. The farmers or breeders have to pinpoint which varieties are doing better. In order to do this, they have to measure the crop, which is a difficult, labor-intensive, and inaccurate job when done with people. We can automate this with gantries, but that would be in limited areas. Drones are a great solution, but drones don't really see under the plant canopy, so they leave a lot of information on the table. Robots are what we really need. So the first product that EarthSense developed is the TerraSensia robot, which is a compact robot designed to fit in between the rows of corn. It's a 15-inch robot, so it can fit within the 30-inch rows as well as the smaller rows in India and other Asian regions. TerraSensia is very rugged, even though it is tiny. It is designed to, again, fit between the rows of corn and collect data. It's been validated across various fields, including in dry and rubbly ground, and in India, in chili fields, sugarcane fields, mango fields, and is designed to be carried by people on motorbikes. Now, just because this robot is small, don't think that it is weak. Here, our engineer is loading the robot up with weights. Then he will sit on the robot, and then the robot is strong enough to pull an entire tractor. So small is not weak, and these robots developed by EarthSense are real agricultural machines. They are also autonomous, and we have been testing them very heavily in various field conditions. So here you see the robot autonomously following the row using sensors on board, even though I'm trying to give it a hard time. What the robot is doing internally is that it's getting sensor data, in this case from the LiDAR sensor that's on the robot. The sensor data is very noisy because of the unstructured environment that the robot is operating in, with the leaves and all the other things that crops have. But we have algorithms that can find the lines and the rows and allow the robot to follow the rows. We also have technology at EarthSense to do this with machine vision, such as shown in this example, where the cameras of the robot are allowing the robot to follow rows of corn at different growth stages with lots of clutter. With this, EarthSense has launched its phenotyping product, of which I'll give an example here. So this is a corn ear measuring robot with a sensor on board that can detect and measure the height of ears of corn as the robot drives through the crop. The AI that has been developed can track the ears of corn and measure their height. This data is provided to the breeders in the form of a user-friendly interface on the TerraSensia.co website. This is an example of the CROPS National Science Foundation project, where each of these grids represent a plot that the breeders are trying to monitor, and ear height and plant height are two of the phenotypes that are being measured. And the data that is coming from the robots has been validated extensively against human measurements and shown to correlate really well. In fact, we know that the data from the robots is more reliable and more repeatable. Now let's talk about the Terrapreta robot, which is designed for farmer-facing applications, and in particular for cover cropping. So most of the US farmland is left bare for 8 months of the year when it's the winter and part of the fall and the spring, primarily because farmers don't really have the time to use a regenerative technique like planting cover crops. And so when you fly over Champaign near Thanksgiving, you see these large corn and soybean desert. EarthSense has been developing technologies to address this, and I will play a video about this now.
Agriculture is the backbone of our civilization, and right now it's threatened by climate change. To grow food for 8 billion people, farmers today have to deal with more frequent and intense droughts, floods, and deteriorating soil. At EarthSense, we've created technologies that'll help farmers produce better food, more resilient soil, and even help reverse climate change. And cover crops are the key to doing that. Cover crops are plants grown not for food, but to capture and store carbon in the soil, making farmland more productive. They're seen as crucial for sustainable agriculture and fighting climate change. They're kind of a big deal.
Farmers planting cover crops so they can reduce the carbon dioxide in the air and get paid for doing it.
Even so, only less than 5% of American farms plant cover crops because of expensive gas-guzzling tractors and skilled labor shortages. Since 2020, EarthSense has worked with farmers to build AI-driven robotics to make cover cropping simpler and more affordable. Terrapreta is our low-cost autonomous robot designed for cover cropping and powered by renewable electricity. Now farmers can have fields with robotic fleets that autonomously plant cover crops and, unlike large tractors, do it without damaging the cash crop. With already 30,000 acres signed up by farmers worldwide, Terrapreta's advanced AI and low-cost hardware make it easy to start cover cropping all around the world. So let's work together to make agriculture a positive force for the planet by helping farmers put billions of tons of carbon into the ground, make agriculture climate resilient, and heal our planet.
We've been testing the under canopy cover crop planting technique with the EarthSense robots at the Farm of the Future, and we have noticed that when we plant from under the canopy with the robots, we get a much better stand in the fall and also in the spring as compared to when we plant with tractors after harvest. Finally, I'm going to talk about the TerraMax, which is a larger robot with 500 kilo payload that is designed primarily right now for palm oil. Palm oil is a very important crop for India. Most of palm oil is currently imported, and India would like to be self-reliant on palm oil. But palm oil cultivation is expensive. Robotics can reduce the labor cost and make smaller farms more productive for palm oil. EarthSense has developed the TerraMax robot for palm oil cultivation. TerraMax is a dual Ackermann system that can tackle really challenging terrain, is designed to be modular. So in the middle here, you can put different kinds of payloads. It's highly rugged, fully electric, and can operate in really challenging conditions in India and of course also in Asia. This is TerraMax with the fertilizing bin installed on it. We're quite excited to launch the TerraMax project in India in collaboration with our collaborators, Akshay Agri. So this is where I'd like to end my talk. My colleagues, Preeti Chowdhary from EarthSense and Robesh Maiti from Akshay Agri are here. Together, we're looking at how we can launch robotic products into India so that robots can be used across all sizes of farms and especially the small farms in India. Thank you very much.